Welcome to The Explainer. Today we're going to pull back the curtain on programming. We're going to break down the simple, core ideas that power pretty much every app, website, and digital tool you've ever used.
So let's just dive right in with this question. How do you actually teach a machine? I mean, a computer is incredibly powerful, but it literally knows nothing. It has zero intuition. So how do we give it instructions to solve problems for us?
Okay, so first things first. We're going to start by framing programming not as, typing mysterious, complicated code, but as something much more fundamental. It's really just the art of giving perfect, unambiguous instructions.
When you get right down to it, a computer is basically a data processor. It's absolutely brilliant at taking in raw data, things like numbers or text or a mouse click, and spitting out structured, meaningful information. But here's the catch. It only does exactly what it's told. That's both its biggest weakness and its greatest strength.
Which brings us to our challenge for today. We're going to create a set of instructions for one super simple goal, telling a computer whether a number is even or odd. Now, for us, that's a piece of cake, right? But for a computer, it requires a perfect step-by-step plan with absolutely no room for error.
And here's the thing. Before we even dream of writing a single line of code, we need a clear plan. And that plan has to be in a language we understand, plain old English. This is where the real problem-solving actually happens.
And that plan has a name. It's called an algorithm. Honestly, the best way to think about it is like a recipe for a cake. It's a super precise step-by-step guide that, if you follow it exactly, you're guaranteed to get the same delicious cake every single time. No guesswork, no ambiguity.
And here it is. This is our algorithm, these 6 simple steps. Well, they contain the complete logic. You can see the flow, right? We start, we get a number, we do a very specific bit of math, and then we make a decision based only on the result of that math. This is our blueprint.
A lot of the time, programmers will actually draw this out using something called a flowchart. Each shape means something different. That oval, that's your start and stop. The parallelogram is for getting input or showing output. A rectangle is for any kind of processing. And that diamond, that one is crucial. That's a decision point.
All right, so we've got our human-friendly plan. Now, how do we translate that into something the machine can actually understand and, execute?
And this is where programming languages come in. They are, essentially, translators. See, at the very lowest level, the computer only understands machine language, which is literally just ones and zeros. Not exactly human-friendly. So we use what are called high-level languages, like C, which uses commands that look a lot more like English. It's way, way easier for us to work with.
And speaking of code, this simple line is probably the most famous line in all of programming. Hello, world. It's the iconic first step, almost always the very first thing anyone learns to write. That printf part is just a built-in command, a function that tells the machine, hey, print whatever is inside these quotes directly to the screen.
Okay, so remember we need to get a number from the user? Well, we need a place to store that number, and that place is called a variable. The easiest way to think of it is like a labeled box in the computer's memory. We give the box a name, we put a piece of information inside, and then we can find it and use it whenever we need to.
But there's a rule. You can't just throw anything you want into the box. You have to tell the computer what kind of data is going in there. Is it an int for an integer, a whole number? A float for a number with a decimal point? Or maybe a char for just a single character? Specifying the type helps the computer set aside just the right amount of memory for our box. All right, so we can store data. But the real magic, the true power of programming, that comes from these next 2 concepts. Let's look at the 2 most powerful tools a programmer has, making decisions and repeating actions.
First up, conditional statements. This is the fork in the road for our program, just like that diamond shape in our flowchart. We use something called an if-else structure, which lets us tell the computer, if this condition is true, do this. Else, if it's false, do this other thing instead.
And this right here is where our algorithm's logic becomes real code. After we divide the number by 2, we check the remainder. The code asks a simple true or false question. Is that remainder exactly equal to 0? If it's true, the number is even. If it's false, well, it has to be odd.
So checking one number is pretty straightforward. But what if we needed to check 1,000,000 numbers? I mean, you can't just write the same code over and over and over again. That would be insane.
So how do you do it? How do you get a computer to perform the same task again and again without rewriting the code?
Well, the answer is the second core concept of programming, and it's what makes computers so incredibly efficient.
The answer is a loop. A loop is just a structure that tells the computer to repeat a block of code, like our even or odd check, until a specific condition is met. We can tell it to run exactly 1,000,000 times, or just to keep going until we run out of numbers. It is the engine of automation.
Okay, let's zoom all the way out. We've been looking at the tiny building blocks. Now let's see how these simple, fundamental concepts are the foundation for all the software we use every single day.
I really want you to let this sink in. Those 3 simple ideas, storing data in variables, making choices with conditionals, and repeating tasks with loops, are basically universal Lego bricks. You can build anything out of them: a payroll system, library management software, even every single app on your phone. They all come down to these core components.
So really, the journey from our simple even or odd checker to a massive global application, it's just a matter of scale and complexity. It's more variables, more decisions, and more loops, all layered and woven together to solve much bigger problems. But that core logic, it stays exactly the same.
Every single app on your phone, every piece of software you use, started with these simple rules. So it makes you think, what problem would you solve first? Thanks for joining us on The Explainer.